Alright, now we're going to try a little more complex truth table. And eventually we're going to evaluate this compound statement P and not Q or not R. Now if you're wondering where these trues and falses came from over here, we have three statements, P, Q, and R, and these are all the possibilities. True, 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 false, true, so on and so forth. You've got three statements, each one has two possibilities, true or false, so you have 2 to the third or 8 combinations. So there you go, that's where those 8 come from. So anytime you do a 3-statement truth table, you're going to lay it out like this. Those are given. Now I'm going to take these trues and falses from P, Q, and R, and I'm going to put them over here into my compound statement, and then we'll start to work it down until we have just one column, and that'll be the what they're looking for in this question. So here's my P, and that's going to be true, true, true. All I'm doing is taking it from over here. False, 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 false. Next will be my Q, and that's 2 trues, 2 falses, 2 trues, 2 falses. And finally my R, which alternates, starting with true, true, false, true, false. It's not as easy as it looks writing these upside down. That's an F, false. Alright, now I'm going to start to evaluate that. And remember, these parentheses act just like they do when you're doing an algebra problem. So we're going to work everything inside these parentheses first. The result of that will be here. That'll be the result of what's inside the parentheses. Then it's not much on this side of the or, just the negation of R. We'll work that and we'll compare what comes out here and here using the or. So this will be the column that our final answer is in. Simple enough? Alright, let's do our negations first. Not R would be false, true, false, true, false, true, false, true. Negation of Q. False, false, true, true, false, false, true, true. Now let's work what we have inside our parentheses. We're comparing P and not Q. So we're doing this column and this column. And we know with the and, the only way for an and to be true is if they're both true. Otherwise it's false. So true and false is false, true and false, false, true and true, true, true and true, true, false and false, false, false and false, false, false and true, false, false and true, false. Now we're comparing. Now you got to make sure you keep up with this thing. I just drew my little arrows here. This column and this one right here, and we're using the or, the disjunction. All right. So we have false or false. Now we know with the or, it's only true if one or more are true. So it's only false once when they're both false. So false or false is false. False or true, true, true or false, true, true or true, true, false or false is false, false or true, true, false or false, false and false or true, true. So, in this example, our answer is this entire column. And why is it this entire column? Because we didn't specify what P, Q, and R were as far as truth values. We wanted to evaluate it for every value of P, Q, and R. So we get 8 results, 8 different results. And that's how you do a little more detailed truth table.